let's look at this one. We have cosine squared t minus sine squared t is equal to which of this right here? Notice that both of these terms, they are in terms of sine and cosine already, so I don't need to do the usual step, right? But I still have to identify this is equal to which of this. And it seems to us that we have a difference of 2 squares. Maybe we can factor it, but if we factor it, we will end up cosine t minus sine t in the first parentheses, and then times cosine t plus sine t in the second parentheses. And that is now one of this right here, neither. So in this case, what can we do? Well, let's notice that this is not just a cosine t, this is a cosine squared t. And for cosine squared t, we do have an identity for this, right? This is the same as 1 minus sine squared t. Let me just use this right here to replace cosine squared t, all right? And in fact, yes, there's also an identity for sine squared t. That's the same as 1 minus cosine squared t, right? But let me replace this right here with cosine squared t. That's how you do it for this equation. And we will just continue. We will just put down the minus sine squared t. And the reason that I want to keep the sine squared t right here is because you see that this is minus sine squared t, and then we minus the same term again, minus sine squared t. This is minus 1, and this is also minus 1. So altogether is minus 2 of them. Therefore, this is the same as saying 1 still all the way in the front, and then minus 2, and then sine square t, right? So we kept this right here so we can combine like terms. And when you replace the cosine squared t with this right here, and once again, this is the Pythagorean identity, another form, right? We combine the like term right here, and we end up with 1 minus 2 times sine squared t, and this is answer choice B right here. And that's it.